So in today's video, we're going to be going over the position, velocity, and acceleration equation and how we can use calculus to derive each of the equations. For example, like how velocity can be derived by taking the derivative of the position, and how acceleration can be derived by either taking the first derivative of velocity or the second derivative of position. The equation we're going to be using to test this out on is going to be our velocity equation, and specifically the final velocity is equal to the initial velocity plus acceleration multiplied by the time. And we're going to actually be going from acceleration to velocity, and in order to do that we can't really take any derivatives. We're going to have to take an integral, and so we're going to be using the fundamental theorem of calculus. And just as a refresher, the fundamental theorem of calculus is the integral from a to b of f of x d of x is equal to f of b minus f of a. Now, since we're starting with acceleration, we have to remember that acceleration is the derivative of velocity, and derivative is basically going to be like your slope. So on the velocity graph, it's on the velocity graph, the slope of velocity is acceleration. So we want to set those equal to each other to represent acceleration is equal to the change in velocity over the change in time. Now, since we want to have velocity by itself on one side of the equation, we can bring dt next to a, so that way we have velocity by itself, as seen in the next step right here. And in order to get rid of the dv, we can integrate on both sides of the equation, where on the left hand side we'll have integration from the initial velocity to the final velocity, and on the right side we'll have the integral from 0 to t. And once we process that integral out, we'll have the final velocity minus the initial velocity and at minus 0. After we solve for the final velocity, we get the final velocity is equal to the initial velocity plus the acceleration times the time, which is the equation we have up here.